Let's talk about the sun. We all know that it's a massive yellow ball of fire, right? Well, if you just said yes, I have good news for you. You are 100% wrong, both in the color and the fire part. When you think about it, it actually makes a lot of sense. Like, what key things do you need to make fire? Heat, the right type of fuel, and of course, oxygen. And what can you not find in space? Well, probably most things, because there's like nothing in space. But most importantly, oxygen, which is the main thing you need to actually make fire. So what is the sun made of then? Well, the sun is actually a giant LED powered by hamsters on treadmills. Nah, I'm kidding. It's more like a literal nuclear explosion with the power of 15 million nukes per second. The sun's energy comes from the immense pressure and temperature at its core, and then some science stuff happens which I'm way too underqualified to explain, but it releases a lot of energy. Also, the sun actually emits every single color you can imagine, which makes it look white, not yellow. The only reason it looks yellow from Earth is because the government made everyone slightly colorblind just to trick us. Same reason why bananas are actually blue. The shorter wavelengths like blue and violet light get spread out, and they're spread out too much for us to see them directly, so we're only left with the yellow color you see when you look directly into the sun. Actually, did you know that's a myth too? It's perfectly healthy to stare directly into the sun, but only if you're doing it for longer than 5 minutes. I'm just kidding, please don't actually do that. Alright, I'm gonna upset a lot of people with this next one, so consider your childhood completely ruined with this one. You know that song, Twinkle Twinkle Little Star? Yeah, turns out it's a complete lie. Because stars apparently don't even twinkle at all. Like, not even a little bit. It might sound really shocking, since stars are just really far away sun, so it makes sense that they would twinkle from all the flares coming out of them. But no, turns out that it's way less cool and kind of upsetting, really. The effect comes from Earth's atmosphere, so when the light from the stars goes into the atmosphere, it hits the moving air inside of it. The air then bends the light into different directions because it's always moving, which makes it so the light takes a different path to your eyes. That's also what makes it look like the light is changing. So I guess the song should be Twinkle Twinkle Air, but that's dumb, so I see why they didn't do that. Speaking of planets, it makes sense that the planet closest to the sun is the hottest, right? I mean, it just makes sense since it's closest to the sources of heat, meaning it would be hotter. But it turns out that's just very wrong. Mercury is closest to the sun, and its temperatures go up to 430 degrees Celsius during the daytime, which seemed kind of low when I first read it, since I assumed it would be thousands, considering it's right next to a giant nuke that would make even the US jealous. But things get even crazier when you see that the temperatures drop to negative 180 degrees at night, which is like at least 2 degrees colder than doing the ice bucket challenge. So what is the hottest planet then? Well, turns out it's good old Venus. During the day, temperatures on the surface can rise up to almost 464 degrees Celsius, and that's literally hot enough to melt lead. The reason why it's so hot there is because of the greenhouse gases on the planet, which traps all the heat inside of it, same as the ones on Earth. So next time someone tells you global warming isn't a thing, tell them to quit being annoying and show them this video. Actually, you might as well just subscribe now so it's easier to find later. Do it. But unlike Venus, space itself is known for being very cold. I mean, you can see in a lot of movies, people accidentally go into space and they instantly freeze up or straight up just explode. And the funny part about that, outside of the exploding part, that's also pretty funny, is the fact that it's not even real. Well, sort of. The temperature in space really depends on where you are, as there isn't really a single temperature in space. For example, if you were near a massive star, it would be extremely hot. Heat gets measured by how many particles are moving around in space, so when you're near a star or a hot planet, there would be a lot of particles moving fast in one place. But the further you go out, the more particles spread out, making it less hot. That doesn't mean there isn't coldness in space though, because if you're near a gas cloud, it can get as cold as negative 500 degrees. So you can still freeze to death in space, but not nearly in the insane way they show it on TV. It would take hours for you to freeze to death in space, but you wouldn't have to worry about that because you'd be knocked out within 15 seconds from lack of oxygen. Let's see what would happen if you were outside the ISS space station without a spacesuit, for example. For starters, you'd be dead within 90 seconds from decompression and your blood boiling, so let's imagine that that's not an issue. Well, since the sun is so extremely warm, it would burn the side of your body that's facing it, since it can get hundreds of degrees warm. But while that's happening, the other side of your body would get very cold. You still wouldn't instantly freeze, but over time it would get too cold for you to be alive. I wonder if there's a perfect speed that you need to rotate so your body keeps the perfect temperature from the coldness and the heat. Kinda like those things that they use to keep hot dogs warm. Anyway, while we're on the topic of dying a gruesome death in space, did you know that being in an asteroid belt is not nearly as scary as you might think? Of course, you can still get hit by a moving asteroid which would turn you into the skinniest person alive, or, well, actually probably dead. But being in an asteroid belt isn't even close to what it looks like in media. In pretty much all movies, shows, and video games, asteroid belts look like these giant waves of rocks that you have to skillfully go around so you don't get hit, and they make it look like there's thousands of them in a small space. But that's actually not even close to what they look like. To get a better idea of how far each asteroid is to the next one, it's like the distance from the US to the North Pole, times 100. Yeah, so each one is more than 600,000 miles apart from the nearest one, but it can even go into the millions. That's more than double the distance from the Earth to the Moon, and these asteroids can go up to roughly 1/5 the size of our Moon, so yeah. Next time you're watching a movie with someone and they dodge asteroids, tell them, actually, it wouldn't look like that because they're much farther apart in real life. Never mind, changed my mind, don't be that guy. But if you are planning on being that guy and you're watching a movie about space, just mention the fact that astronauts aren't actually weightless. Instead of being weightless, they're actually always falling down to Earth. It might sound weird, but it's similar to the feeling you get on a roller coaster going over a hill or in an airplane experiencing a sudden drop. In both cases, you feel weightless because you're falling down at a high speed. And you might be wondering how the space station hasn't turned into a giant crater from crashing into the Earth at 17,000 miles per hour. So, let me explain. The space station doesn't crash into Earth because it's not falling straight down. It's also moving sideways at very high speeds. Imagine like throwing a ball. The harder you throw it, the further it travels before hitting the ground. If you can throw it hard enough, the ball will travel so fast that as it falls, the Earth curves away beneath it. That's exactly what happens with the space station. The ISS travels at an insane speed of about 17k miles per hour, and the high speed means that as it falls towards Earth, it keeps missing it. The space station is pretty much falling around Earth in a loop. Astronauts are actually trained for that before they get sent into space, in something they call the Vomit Comet. This thing is just an airplane that keeps going up and down to make the astronauts feel weightless. And to transition, one thing you definitely don't want to see up there is a black hole. Black holes seem very dangerous and deadly. These guys are really misunderstood, to be honest. They're actually kind of chill. A lot of people believe that black holes suck anything into them from millions of miles away, and that we would be screwed if one popped up near us. But as it turns out, that's not true at all. Turns out that black holes can only suck things up depending on their size. For example, if our sun was replaced by a black hole, we wouldn't even notice it. Well, if we're talking about the gravity. I heard our sun is pretty important for solar panels. But outside of solar panels, we wouldn't notice it at all. So while black holes might look pretty cool, explosions in space really wouldn't be. If something exploded in space, it wouldn't be a massive boom with a fireball. Instead, it would just be a flash with a lot of force, and that's it. Yep, no cool fireballs, just a really bright flash, and then everything around it would shoot outwards in a straight line. For example, if we launched a nuke into space, it would just be a bright flash with no mushroom cloud or fireball to follow it. There's also no sound in space, which is a very, very good thing. Sound doesn't travel in space because it needs to move air molecules in order to actually make the sound travel. And there's no air in space, obviously. But if we were able to hear sounds in space, we would hear the constant thermonuclear explosions of our sun. Anyway, YouTube thinks that you'll like this video next, so click it. And if you made it to the end, subscribe.